Now children, let us start with the exercise 3. In exercise 3, it is given that you have to write this square root in words. Now first it is given root of 324. So this can be written in words, square root of positive 4. Now you can write in words, that means you have to write completely in words. I'll put it in this way, positive 324. The second sum, they have put the sign, negative sign before this root. So it means the negative square root of, that is negative square root of 324. Same way you can write for this two number, as the negative sign is there before the root sign. So it is negative square root of 625 square root of 625. And as there is no sign, that means it is a positive. So you will read as positive square root of 625. The next question is, it is given in words and you have to write in symbol form. So the first is the positive square root of 400. So this can be written without any sign before the root, as positive doesn't carry any sign. So this can be written under this root sign 400 inside it. That means the positive square root of 400. The next is given the negative square root of 81. That means you have to put the negative sign before the root. So this is the symbol. You have to use the root symbol, then 81 inside it and the negative sign before it. For negative, it is necessary to put this sign. For positive, it is not compulsory. Now the negative square root of 21 is, again I have to put negative sign and then write inside that symbol 21. Now the positive root of 1 is, you can write it like this. The next third question is asked about, you have to write the values. Value of, now when it is given negative, that means I have to take the negative root of this. So now root of 9 is 3 and minus 3. As it is given minus, so I will take only negative root. Here in the second question, it is given root 25 and no sign is there. Sorry. So I will take just root 5, positive root. For the third question, it carries negative sign. So I will take minus 5. Again for fourth question, again there is negative sign before it. So minus 11 is the value of this. And for last question, that is root 100, I have to take positive 10. So this way it is clear for you that whenever negative sign is given, I have to take only negative value, and when no sign is there, then I have to take positive value. Hope so this is clear with you. Now children, let's consider another topic in this chapter, that is perfect squares and non-perfect square. Now consider these numbers, that is 2, 3, 4, 5, 20, 27, 64, 81, 93 and 100. These numbers I can divide into two groups. That I know this, 4, 64, then 81 and 100. These are the perfect square, as these have the integers which are multiplied by itself gives me this number. Now, as you know, 4 is the square of 2. That is 2 into 2. So, this is a perfect square. Again, 64 is the square of 8. That is 8 into 8, which gives me 64. Then, 81 is, again it's a 9 square. That is 9 into 9, gives me 81. Then, 100 is also a perfect square, as 10 into 10 gives me 100. So, the numbers which gives me exact same number when multiplied by itself, and then it gives me this number, these number are known as a perfect square. But let me see with the other group, that is 2, 3, 5, 20, 27 and 93. When considering this number, I know there is no integers, two integers which I multiply, they are same, and that will give me this answer. Suppose if I take 2, it is 1 into 2. So here it's not the same. So this is not a perfect square. Again 3 if I take, it is again 1 into 3. The number are not same, the multiples. So again this is also not a square. Same thing with 5, 20, 27 and 93. So these kind of numbers where no integers are multiplied by this kind of numbers where no integers give me this square. So these are known as non-perfect square. To find the square root of this perfect square, we have learned by division method, and it has a square root. 4 has an exact square root, that is 2, 64, 8, 81, 9 and 110. Here we have seen that these numbers does not have any exact square root, so these are known as non-perfect square. But even this non-perfect square do have roots that I will explain you further. Now let me show you how to find the square root of non-perfect square as it is given in your book. The 20 is non-perfect square. So I can write 20 and then take after point 0, 0 at in 4th place so that I can continue solving this sum. Now first number is 20. I will make the pair of 2, 2 and before the decimal point the number is 20. So the square which is very near to 20 is 4 square, that is 4. So I will take first number 4. 4 into 4 gives me 60. After subtracting it, 4 is remaining. Then I will take this 2 both 0 down and that makes 400. Now again to get this number, I have to put a number over here. Here it is taken 4. So 84 into 4 gives me 336. Now after deducting it, I get 64. The next step is I have to take this 2 below and then it makes 6400. And then same number I have to add over here and it gives me 88. Now next step is that I have to take such a number that multiplying by it again gives me something that is near to 6400 or exactly the same. When I take 7, it gives me, after multiplying it, 6209, and again we have to deduct it and I get the remainder 191. So still it is not completely solved, so I will go further. I will take this 0 below and it is now to again to subtract further, I will take a number. Now let me explain you the example of non-perfect square which is given in your book. How to find out the square root of 20. Now square root of 20 I have written as 20.00000. After making the group of 2 it is solved over here up till 4 decimal point. So I have taken 4 times 0. Now in this book it is given how to find out this root of non-perfect square. Now first, the group of number before the decimal point is 20. So we have to find such number whose square is near to 20. That we know 4 into 4 gives us 16. So here they have taken 4 and 4 into 4 gives 16 and the remainder is 4. The next step, you remember well that I have to take this group of 0 over here and this 4 has to be added over here. So it gives me 8 over here. Now next step, again I have to take such a number which I'll put it over here, multiply the same number so that it should give me number near to it. Now when I'll put 4, so 84 into 4 gives us 336 and after subtracting it we get 64 over here. Then again you have to take 0 below this and then here you have to add that 4, it gives you 88. And then again the next number which they have taken is 7. Now 887 multiplied by 7 give us 6209. And further carrying on, we can see that the dividing it is not getting completely divided. Here in the book it has solved up to 4 decimal point. So we can write this square root of 20 is 4.4721 and then you can put 3 dot. That means it is continuing, it is infinite. So by this we can make out how to find out the square root of. Okay children, now as we have learned the square root of non-perfect square by a division method, now let me explain that this non-perfect square, it also has its square roots by this example which is given in your book. Here the triangle ABC is given and in that length AB or BA is given 2 and BC is given 4 centimeter. Now it's a right angle triangle. So by Pythagoras theorem we can find AC, that is AC square is equal to BA square plus BC square. As they have given you the length of both the sides, I can substitute that value. BA is 2 square and here BC is 4 square. That makes 4 plus 16 and it gives me 20. Now by this we can find out that AC square is equal to 20. That is length of AC is 20, square of length is 20. Therefore we need AC. So AC is root of 20. By taking root of both the sides, I'll get root of 20. So this makes clear that length of AC is root 20. So that means a non-perfect square has also a square root. Now in your exercise 4, they have given a right angle triangle which has a length 7 and 5. Again to find out this, I have to apply the Pythagoras theorem. Let us name this x, y, z. So xy is 7 and yz. Yz is equal to 5. So by applying Pythagoras theorem, I can find out the hypotenuse which is opposite to right angle, that is xz. Now by Pythagoras theorem, xz square is equal to xy square plus yz square. That is xy is 7, so I will substitute that value 7 square plus 5 square. That will give me 49 plus 5 square is 25. So by adding this, I will get 9 plus 5, 14, 1 carry, it is 74. Now, so the xz square is 274. Now, to find that, we need xz is the hypotenuse. So, taking the root of both the sides, I'll get root 74. So, the first answer to this is root 74. Children, we have learned now how to find out square root. Now, we have also seen that there are some numbers which are known as perfect square, like 4, 16, 9, 81, 64. As these squares we get by a same number. When a same number is multiplied by itself, we get the square, and that square, we want to find out the root of that, we get a root. Suppose 4, it gives me, how I get 4? We get 4 by 2 multiplied by 2. So, root of 4 is 2, root of 64 is 8, root of 81 is 9, root of 100 is 10. Now, in the same way, we have square root for this non-perfect square. As we have seen, we don't get the square, but it also has a square root. Now, see, the square root of number, that is not a perfect square. In the last explanation, I have given you the numbers which we divided into perfect square and non-perfect. Like 2, the root of 2 is not a perfect square, as the two same number are not multiplied and we don't get the number 2 by it. So, when I want to 1 into 2, so that is not a perfect square. So, let us see that how a non-perfect square has a root by this example given in your book. Now, a number which is not a perfect square also has a root. Now, this is explained by this example. A right angle triangle is given over here, that is ABC, where B is a right angle, that is, it is an angle of 90 degree, and the distance between B and A, it is given 2 centimeter, and the distance between B and C, it is given 4 centimeter. That is the perpendicular sides of two perpendicular sides of this rectangle. That distance is given, and we have to find this AC, which is hypotenuse of the triangle. As you know that hypotenuse is the side of a triangle which is always opposite to right angle. So here B is a right angle, the opposite side to this angle is AC. So that side is known as hypotenuse. Now this you know well, that to find the hypotenuse, the length of the hypotenuse, we can use the Pythagoras theorem. So by using Pythagoras theorem, we can find the length of AC. Now, what is Pythagoras theorem? You know well, that hypotenuse squared equals to side 1 square plus the side 2 square. You will take BA as side 1 and BC as side 2. So now what is this? Here length AC we have to find. So length AC square according to the theorem is equal to length BAB square plus length BC square. So let me substitute that number over here and get the answer. So here it will be 2 square plus BC is 4 square. Now I'll write what is the square of 2? It is 4 plus square of 4 is 60. So what I am getting over here? I am getting 20. Now you know children that 20 is what? It is AC square. But what we want? We want length of AC. So how I'll get? Squaring the both side. What I'll get? Therefore AC is equal to root of 20. So now what is the length of AC? Now length of AC side is equal to root 20 centimeter. So now by this example we come to know that this length is also a root of, what is it? It is root of 20. That means it has the root. So non-perfect square, here 20 number is a non-perfect square. It is not a perfect square. So when I get this length, AC square is 20. So AC I need. So AC is the length of that hypotenuse. So this I will get by squaring both the sides. When I square both the sides, I will get AC here and the root of, sorry, here not squaring, taking the root. What? Taking the root of both sides. Of both sides. So what I'll get? I'll get the length of AC. So AC will be root of 20. So the length is root of 20, that is 20 centimeter, root 20 centimeter. So that means this number non-perfect square also has a root. Okay children, as I have explained you, there is a root for non-perfect square also, and we have already solved example from your textbook. So now let us be more clear with it by solving the exercise 4. And here also, when we want to find a diagonal of a square, diagonal of a rectangle, you know that very well. A rectangle is what? A rectangle is a polygon with 4 sides and all the sides are right angle. So naturally, when I'll draw a diagonal, then I will get a right angle triangle. Same with the square also. Square is a polygon with all 4 sides equal and there are 4 right angles in it. That means all the sides are perpendicular to each other. So again here when I will join the 2 opposite vertices, I will get the diagonal, and that diagonal will be again, it will form 2 rectangles. So right angles. And what is right angle? A right angle is a angle in which one angle is always a 90 degree. So to find in a right angle triangle, when a side which is opposite to right angle triangle, that is angle which is 90 degree, opposite to that 90 degree, the side is always hypotenuse. And if we want to find the length of hypotenuse, we have to follow Pythagoras theorem. And that Pythagoras theorem just I have explained you in the solved example. With the help of that, we'll solve these 3 sums given in your exercise 4. Now in the first sum in your book, it is given that a right angle triangle is given, and that right angle triangle we have to find what? The hypotenuse of this. What is given now? It is given the length is 7 centimeter and height is 5 centimeter. Now by Pythagoras theorem you know hypotenuse square is always equal to side 1 or length square plus height square, and it is always possible only in right angle triangle. So here length is given 7 square and what is height given? 5 square. Now I'll take the square of 7, that is 49, and plus square of height, that is the other side of a triangle, that is 5 square, and that will give me 25. Now I will add this. Now 9 plus 5 gives me 14. 1 will carry that, and then 1 plus 4, 5, 5 plus 2, 7. So here I am getting 74. What is 74? It is hypotenuse square of that right angle. But I need this triangle. Suppose we can give PQR. So I want the length of PR. I don't want the square of PR. So therefore, what I'll do? I will take the root of both the sides. So here hypotenuse is equal to root of 74. So now what is the length of hypotenuse? I can say length of hypotenuse is equal to root 74 centimeter. Here one thing is always necessary. You have to remember that you have to write your answer along with the unit. Whatever unit, if it is given centimeter, you have to write centimeter because it gives the distance. So distance, whenever you are writing a distance or length, you have to write the answer along with the unit. So here the centimeter is the unit given, so I am writing that in the answer also, right? Now we'll move to the second sum. In the second sum, they have given you rectangle, and rectangle, again they have asked the length of the diagonal. Here, suppose this is A, B, C, D. Now what I want the length of BD, right? What is diagonal? Diagonal is a segment which joins the opposite vertex. Now B is opposite to D, so it joins that. And you know a rectangle is always having all the angles, 4 angles are right angle. So this angle A is a right angle and this side BD is opposite to it. So that is hypotenuse. Now again using the same theorem, that is Pythagoras theorem, what I'll get, length BD square will be equal to length AB square plus length AD square. Now first we have to write that and then substitute the values. Now AB is given 12 centimeter, so I'll write, substitute that value, and here AD is given 7 centimeter, so I'll write here 7 square. Now what is the square of 12? As you know very well, it is 144, and square of 7, it is 49. Now you have to add this both to get the length of diagonal. So 9 plus 4, 13, 1 carry, 4 and 4 are 8 plus 1, 9, and this is 1. Now you got 193. What is 193? It is length of BD square. And what we want? We want BD. So therefore, taking the root of both the sides, I will get it. Therefore, length BD will be equal to root of 193. Therefore, I can write 193 centimeters. So now this is the length of this diagonal which is asked to you in this sum, right? So here it was asked the diagonal, what is the length of diagonal? As rectangle is having all the angles right angle, so when I join this diagonal means I am getting a 2 right angle triangle. So here again you have to apply Pythagoras theorem, and then you will get by help of the Pythagoras theorem, you will get this diagonal, and that is 144 plus 49 square, it gives me 193. It is a square of that. So when I want the length, real length, so I will take the root of both that, BD, length of BD. So that will be root of 193, right? Now we will move to the third example. Now a third question. In this also they have given you square. And what is square? You know the square has all the sides equal. So they have given side 8. So this is also 8 centimeter. This is also 8 centimeter. This is also 8 centimeter. Now they have asked you to find the diagonal. So diagonal, suppose if I give the name here S U V T. Okay. Now diagonal means joining the opposite vertex. So I'll join this UT. Now I want to find this. As you know, the square has equal sides and all the angles are right angle. So I can apply Pythagoras theorem also here. As Pythagoras theorem is always applied for a right angle triangle. So again, applying that right angle triangle, I can find this UT distance. So that is a diagonal. So it is also a hypotenuse because it is opposite to the right angle triangle. So again, applying the Pythagoras theorem, length of UT square will be equal to length of SU square plus length of ST square. Then what I do? I will substitute the value. As the length of the side is given 8. So I will write 8 square plus 8 square. Right? Now as the sides are equal, so it will be 64 plus 64. Now I'll add both. 4 plus 4 you know 8 and 6 plus 6 is 12. So here it is 128. 128 is the length of UT square. But what I want? We want the length of diagonal, that is UT. Therefore, to find UT, what I will do? Length of UT, I will take the root of both the sides. So taking the root, I will get root of 128. So what is the length of diagonal? So length of diagonal is what? That is root of 128 centimeter. Again, as I told you, you have to write the centimeter because it is a unit and the length is always measured in the centimeter, meter, whatever unit is given in the question, same unit you will follow here. Now, I think it's very clear with you how to find the root of non-perfect square. Now we will solve the exercise number 5 and 6.